Hello dear students, how are you all? I hope that you all will be fine. So here I Sandeep Kumar on the behalf of Shiv Jyoti Education Group Kota, welcome back you all in the class of statistics. As you know that in the previous class we discussed about the classification of data. In that chapter or in that video we consulted many of the topics related to meaning of classification and organization, methods of classification and different types of series as well. Okay, so today in this class we are going to learn about the extension part of the same chapter और आज की इस क्लास में हम कौन-कौन से टॉपिक्स को डिस्कस करेंगे. So let's proceed ahead. So under this part we will learn about the topics such as frequency, that what is meant by frequency, or we can say that what is the actual role of the frequency under statistics. Next is types of frequency distribution, as this frequency can be of many of the types. So what are the types of the frequency distribution, that will be discussed here. Next is frequency curve. It proves that we can convert this frequency distribution into many of the curves also. So how to draw such kind of curves and all, that will be known under this head, right? And the last one is univariate and bivariate frequency distribution, which is also a very important type of the frequency distributions. So now children, let's proceed back to the DG board for the discussion of these given topics. So students, if you have frequency, the number of the times an observation is repeated in a given period, or the number of time an observation occurs in the raw data. Means to say, when any of the data is getting the repetition again and again while calculation of the data, or while the collection of the data, or we can say in the very simple language that the density or the repetition of any of the particular single or many of the quantitative data is termed as frequency. As you have this example also, a survey is carried out from a group of children to know their favorite color of the rainbow. If yellow color is chosen 30 times, it gives the yellow color a frequency of 30. So the density of yellow color is 30, repetition of yellow color is 30, that is why this is known as the frequency of yellow color, which is 30. Next it comes frequency distribution. A frequency distribution is a list of all values that a variable takes in a sample, or it is a tabular arrangement of given numerical data showing the frequency of the observations. I repeat the same thing, look at the board only. It is a tabular arrangement of given numerical data showing the frequency of the observation, or you can say that whenever we present any of the frequency of the related numerical facts in a tabular presentation or in a tabular form, as you can see it is here. So that type of presentation of the frequency is termed as frequency distribution. Further, you have this example also, that you have these class intervals 10 to 20, 20 to 30, 30 to 40. As in the previous class, even I told you that whenever we convert the data into these type of classes, these classes are actually known as continuous series. And in the continuous series we find two things, the classes or the groups in the data and the frequency as well. Next we have types of frequency distribution, which I told you that this will be the part of us today's topics. So the one is discrete frequency distribution and the another is continuous frequency distribution. As I have told you that basically we have three types of series. In the previous lecture even I told you that we have three types of statistical series. The one is individual, another is discrete and the last one is continuous series. The presentation of this series, again I am going to repeat, in the individual series we are found only the variables, x variables only we have. Okay, whenever we are getting any of the data in a very simple manner, or only the x variables, x items or x terms are given, in that condition it is known as individual series. But whenever we are getting x variables and the frequency with them, then this is known as discrete frequency distribution. Similarly, if we talk about the continuous, as in the previous slide I gave you example that we are having the classes and frequency with them. Simultaneously, we are getting two things. That type of frequency distribution is known as continuous frequency distribution. It means to that frequency distribution can be of two types only. Reason is that in individual series we have no type of frequency. That is why it is not a part of frequency distribution, but frequency is found only under two series. The one is discrete and another is continuous. That is why the distribution is also as the same. A continuous series or frequency distribution represent continuous variables showing range of values of different items of a series. As this, you can see in this table also, marks are given here 30 to 40, 40 to 50, 50 to 60. This type of data is always presenting itself under the continuous series only, as many of the times I have told you. Frequency, the presence of the frequency is must here in the continuous series. Next type it is, which is known as open-ended series, that we will discuss further, don't worry. So these type of frequency, these type of classes are also included under continuous frequency distribution. Here also you will find two things. The one will be classes that may be open-ended and the next is frequency. Here I have used a term open-ended. What does this mean? Now see, these marks you have 35 to 40. Two values are here. The one is 35 and another is 4040. So this 35 is actually known as the lower limit of the class, which is indicated by L1. Getting my point? This is the lower limit of the class, which is termed as L1, and this is the upper limit of the class, which is indicated by L2. Correct? Here you can see we have only one thing, which is 35, that is the open-ended series. Right? There is a difference. In this type of class, you are not getting L1 and L2 as well. One thing is missing. That is why these are known as open-ended classes or open-ended series. Next it comes construction of discrete frequency distribution, that how can we convert the data under discrete frequency distribution. So these you can see, we have some of the values here, and similarly you can observe this thing that many of the values are on the repetition mode. As 55, 1, 2, 3, 4, 5 times are there. Many are there, like 50 is repeating, 65 is on the repetition mode. So in such a way, we can convert the same data into the frequency distribution, but how can we convert? Now see, there is a particular process. As you can see, values are on the repetition mode. So the first step is that take out the common values, right? Common means only the single time, and arrange them into the ascending or descending order, howsoever you are comfortable with the same. Okay, so the first step is that take out the common values here, convert them into the ascending or descending order. Next is telemarks. What is meant by telemarks? Now you can start from here. This is 56, it is at the one time, so in front of 56 you can mention one telemark. Next is 65, mention one mark. 55, 1, again 55 is here, again 1. In such a way you can complete all the data here in the telebars. After all, you can count these telebars and mention the frequency here. This converts the data into the discrete series, and it is now very simple to use. As you can see here that we are having the limited data here with us, only limited figures are there. But whenever we collect the data on a huge level or on the large level, at that time we are having an ample of quantitative data or the quantitative figures. At this situation, that is not easy to understand or easy to use. Suppose the repetition of the 55 is 7 to 9, that means 729 times. So that is not easy to count again and again for the people, those who are using such type of data. So to make it understand, to make it easy, and to make the such kind of data useful, we have to convert this into the continuous discrete series. Next it comes construction of continuous frequency distribution. For this we need to have determined range. Range should be there, as in the previous table we saw 35 to 40. So the range is only 5, right? So according to the data, according to the uses of data, we can change or we can decide the range of the data according to our convenient. Next, determine the classes. From where should we start the class? Maybe from 0 to 10, 0 to 5, 0 to 100, or depends upon the data. Next is class interval. What does the class interval mean actually? You may have observed that in the previous slide I show you the marks. So the marks were 35 to 40, 40 to 55. L1 and L2 already I have told you. So the difference between L1 or L2 of any of the particular class, I repeat, the difference between the L1 and L2 of any of the class is known as this class interval. So again I take you back to the same table. The data was 35 to 40, 40 to 45. So the class interval is 5. Got it? Next is total frequency. That I'll let you know in the next example, or you may have got this, that what is meant by total frequency. Whatever the frequency we are mentioning there, the total of that frequency should be matching with the number of figures which are given to us. Next is class frequency, repetition of the classes, and only the individual frequency of any of the class. The next is class limit. From where should we extend the classes? That means what will be the actually last value of the classes or the data. So individually it comes at what is meant by range. Difference between the maximum and minimum value of the variable is known as range, such as range is needed to determine the number of classes. As you can see the differences here, minimum and maximum, right? So this is the range, the topper value of the classes and just to the bottom classes. These are the differences. Suppose आपके पास जो data provided है उसमें आपको first class given है 30 to 35, okay, and the last class is 70 to 75. So the highest कौन सा हुआ 75 and the lowest is 30 only. So इन दोनों के बीच का जो difference होगा, जो gap होगा, that will be known as range. Next it comes determination of classes. Determine the number of classes once range is obtained and class interval is decided. Number of classes is equals to range, or we can say interval. Such as you have this example, given range is equals to 20 and class interval is 5. Range, that means a gap between maximum and minimum value, and class interval stands for the difference between lower limit and upper limit of any of the particular class. So number of classes will be 20 divided by 5 is equals to 4, and in this way you can design only 4 classes, right? Now if I talk about the range here, the data which is provided here, जो आपको data given है, इसमें range कैसे calculate करेंगे? तो the first class is 0 to 5 and the last is 15 to 20. Maximum value क्या है? 20, 20 and the lowest one is 0. So 20 minus 0 equals to 20 again. So this is the range of the data, right? Next is class interval. What does this mean? What I told, the difference between lower limit and upper limit of any particular class. यहाँ आप देख सकते हैं 0 और 5. This is the lower limit, this is the upper limit. दोनों के बीच का gap 5. Further again the gap is 5, the gap is 5, the gap is 5. Next is class interval. Difference between upper and lower. Class limit is called class interval or class width. As you can see, class is 5 to 10, so the interval is 10 minus 5. That already I have told you कि यहाँ आपको L2 में से L1 को minus करना होगा. So this will be known as class interval. Again it is here 20 to 40. So the class difference or class interval will be 20, क्योंकि 40 minus 20 करेंगे तो the limit will be 20 only. Now these two things already I have told you, upper class limit and lower class limit. You must know about all these things, right? Next it comes class limits. There are two types of class limits. The one is lower limit and another is upper class limit. क्या होता है, कैसे इसे काउंट करते हैं, और how can we observe the same? Class limits क्या होती है बेटा? Two types की होंगी, lower and upper, as I have told you. These are the classes. So focus here only that left hand side value of yours and mine also. Left hand side values are known as lower and right hand side values are known as upper class limits. So you can observe here in this class that 64 is at the left side. So this is the lower class limit and this stands at the right side of my hand. So this is upper class limit. Next it comes midpoint. What is meant by midpoint, or the mid value also we can say to the same. हम इससे mid value भी कह सकते हैं. कैसे calculate होगा? A very simple example is here, or a very simple formula is here. That is what? Upper class limit plus lower class limit divided by 2, or you can say L2 plus L1 divided by 2. As you have seen in the previous class, in the previous slide, that the classes were 0 to 20. Okay, so 0 to 20 stands for here upper limit is 20 and lower is 0. So 20 plus 0 is equals to 20 divided by 2 is equals to 10, correct? Now next is we have methods of determination of class limits. How can we determine the class limits? So that for that sake we have two different methods. The one is inclusive method and the another is exclusive method. और basically आपको जो भी numerical solve करने हैं further, that means in the further chapters whatever the mathematical calculations we will learn, तो उसके लिए जो हमें data provided है that needs to be in the exclusive method only. In case अगर inclusive भी होता है, so at first we have to convert this into the exclusive method for make it useful. Now what is meant by inclusive method? All items including the lower and upper class limits are included in the respective class. The one thing, then another is you can see here is the class 5 to 9. Okay, the class has been given 5 to 9. If marks obtained by students are grouped as 5 to 9, 10 to 14 etc. students who got marks between 5 and 9 will be included in 5 to 9 group. Now see what is the difference or what is the actual meaning of this method. Children, now you can see this is 5 to 9 and the another is 10 to 14. But अभी तक जो भी आपने स्लाइड से की, you may have observed कि वहाँ पे जो आपको डेटा प्रोवाइडेड था वो कंटिन्यूअस में था. Means to say 5 to 9, then 9 to further it should be. Or if it is 5 to 10, then next will be 10 to 15. But here it is a gap. यहाँ आप देख रहे हैं गैप है कि इस वाली क्लास की जो L2 है और इसके नेक्स्ट वाले क्लास की जो L1 है, दोनों के बीच में एक गैप आ रहा है, दैट इज ऑफ 1. तो जब भी आपको इस तरह का डेटा ऑब्जर्व करने को मिलता है, इस तरह का डेटा आप देखते हैं, सो दैट इज अ पार्ट ऑफ इंक्लूसिव मेथड और इंक्लूसिव सीरीज वी कैन से. जबकि एक्सक्लूसिव सीरीज में ऐसा कभी नहीं होता है. दे विल नॉट फाइंड एनी ऑफ द गैप बिटवीन L2 of any class and L1 of the next class as well. Now this you have the another example. Here you can see of the exclusive method it is 5 to 10 and 10 to 15. Hope so there is no gap. You can easily observe the same thing. So this is a type of exclusive method of the series. Next it comes class. What is meant by class? Whenever we are going to convert the data into the classes or into the continuous series, obviously it will be only in the form of classes or groups. As you can see, marks of the statistics are given. Marks are 0 to 5. Many of the students are here. Those who are getting the marks in between 0 to 5. So the number of those students is 15. कुछ स्टूडेंट्स ऐसे होंगे जिनके मार्क्स 5 to 10 के बीच में आए होंगे, so they are 25, and another those who got marks between 10 to 15 they are 5. So this is the type of class. ये जो आप देख रहे हैं in circle, these are the type of classes. Next is class frequency. Number of values in each of the classes is called class frequency. That you can see here. These are the classes. Maybe now you are tuned with the same thing. These are the classes and these are the frequency number of students. So ये हो जाएगी frequency. Frequency class की है, इसलिए इसको हमने कह दिया class frequency. Next it comes the total frequency. That means whenever we are going to do the summation of these frequencies, whatever the value we are going to get, which is total frequency, that can be indicated as sigma f or summation f also. जब हमें बहुत सारी क्लासेस गिवन होंगी, इट मीन्स उनके साथ फ्रीक्वेंसीज भी बहुत सारी होंगी. उन सभी फ्रीक्वेंसीज का जब सम टोटल कर देंगे तो जो पर्टिकुलर वैल्यू हमारे पास आती है, जो डिजिट्स आती हैं, उससे हम क्या कहते हैं? टोटल फ्रीक्वेंसी. Now here is a question for you. That number of values in each of the class is called, the number of values in each of the class is called class interval, class frequency, class limit or the range. I hope the answer should be class frequency, that you can see here also. This next you have frequency curve. Okay, what I told you कि जब हम किसी भी तरह की frequencies को convert कर देते हैं into the graphical presentation, they are termed as frequency curve. Now see what is the actual definition. Graphical representation of frequency distribution is called frequency curve. That only I told you कि जब भी frequency को हम graphically present कर देते हैं in such a way, graphs के अंदर present करेंगे तो उसे हम कहते हैं frequency curve. Class frequencies are plotted on y-axis and class marks are plotted on x-axis. This you can see children, there are two axes, the one is this and another is this standing one. So this axis is known as OX axis, the laying one, it is known as OX axis, and this standing one is known as OY axis. Okay, so we have to plot the data similarly here, that you can see on the OY axis class marks means here, and this on OX axis marks are plotted, so this is here, right? So here this you have a illustration for the same. The class intervals are given here, 10 to 20, 20 to 30, 30 to 40, and the last is 60 to 70. So for the primary step, what we need to do, we will convert these classes into the mid value. Frequency is always given as it is the part of continuous series. तो frequency तो हमें दी ही होगी, इसके बिना तो classes हमारी continuous series में fulfill complete नहीं हो सकती है. So mid value के लिए बेटा I told you formula that L2 plus L1 divided by 2 करना होगा, or we can say upper limit of the class plus lower limit of the class divided by 2, right? तो हमने वही किया mid value के लिए. Classes 10 to 20, तो upper limit है 20 plus 10 is equals to 30. 30 divided by 2 is equals to 15. आ गई mid value. Further 20 to 30, so 30 plus 20 is equals to 50. 50 divided by 2 is equals to 25. तो हमने इस तरह से mid values को calculate किया. Then उसके बाद you can see on the OX axis we have plotted the mid values here. हमने सबसे पहले इन mid values को OX axis पे plot किया. 5, 15 एक particular scale लेना होगा, that you should know. आपने previous classes में भी graphical presentation जरूर सीखी होगी. और इसके बाद जो हमारा नेक्स्ट चैप्टर आएगा वो भी presentation of data है. There also we will learn many of the graphs of the statistics. तो बेटा सबसे पहले हमने यहाँ पे marks को plot किया, right? एक particular scale लिया, scale है 10, 5 to 10, 5 to 15, 15 to 25, so the gap is 10, right? And here we have mentioned this frequency. फ्रीक्वेंसी को मेंशन किया और अकॉर्डिंगली मिड वैल्यू को देखते हुए दैट इज 15, तो 15 पे हमने 5 को प्लॉट किया. 25, तो 25 यहाँ आता है और 25 पे फ्रीक्वेंसी है 12, सो यू कैन सी इट इज 12. इफ आई टॉक अबाउट दिस वन, 55 इज देयर, 55 पे वैल्यू है 14, सो हियर ऑन द 55 इट इज 14. इन सच ए वे वी हैव प्लॉटेड द डेटा ऑन द ग्राफ ओनली. Next is univariate and bivariate frequency distribution. In the previous exams you may notice this thing कि यहाँ से बहुत बार एक क्वेश्चन पूछा जाता है. Maybe the single definition might be of the univariate or bivariate or the difference between both of the distributions. So let's see what is meant by univariate frequency distribution. Frequency distribution that contains only one variable. What it is saying that univariate frequency distribution is a type of frequency distribution that contains only one variable. एक ऐसा frequency distribution जहाँ पे कि हमारे पास only एक single variable है. And what is the variable? That is marks obtained. क्योंकि यही हमारे लिए variable है, यही हमारे लिए terms है, यही हमारे लिए statistical items होंगे. तो बेटा जब हमें सिर्फ एक ही item दे रखा है और साथ में उसकी frequency distribution दे रखा है, तो इस तरह की टेबल्स को हम क्या कहते हैं? यूनिवेरिएट फ्रीक्वेंसी डिस्ट्रीब्यूशन. नेक्स्ट इज बाइवेरिएट फ्रीक्वेंसी डिस्ट्रीब्यूशन. फ्रीक्वेंसी डिस्ट्रीब्यूशन दैट कंटेन्स टू वेरिएबल्स. कोई भी किस तरह का फ्रीक्वेंसी डिस्ट्रीब्यूशन जहां पे कि हमें टू वेरिएबल्स गिवन होंगे. फ्रीक्वेंसी डिस्ट्रीब्यूशन ऑफ टू वेरिएबल. सेल्स एंड एडवर्टाइजमेंट एक्सपेंडिचर ऑफ 20 कंपनीज. This you can see it is talking about frequency distribution of two variables, sales and advertisement. Means both of the things are there, sales and advertisement expenditure as well. तो दोनों चीजों को हम एक ही साथ टेबल में प्रेजेंट करें. This you can see here, sales in lakhs is there and this advertisement expenditure in thousand. So both of the things are there in only one frequency distribution, that is known as bivariate frequency distribution. Now there is a question for you, that frequency distribution which contains only one variable is called, let me know, guess it for the same. Frequency distribution which contains only one variable is called, examples are here, univariate frequency distribution, bivariate frequency distribution, frequency array and frequency curve. I hope the answer will be A, and even you can do the cross study of the same. This is univariate frequency distribution. Okay. So children, today we have completed our chapter number 3, organization of data, and we have learned many of the things here. Those will be really very useful for the further chapters. और ये हमने जितने भी topics complete किए हैं in the part 1 of the lecture and even part 2 of the lecture, इसमें mainly हमारे वो सारे topics हैं जो कि हमें statistics के बिल्कुल last chapter तक भी discuss करने होंगे, क्योंकि ये सारी चीज़ें practical numericals के साथ में practical approach में use होने वाली हैं. So I hope that you may have learned a lot of the things here with your cognition.